In lecture 21, we will discuss the inverse Fourier transform concept. And the previous lectures, we used to explain the inverse formula and the power series method. Now we will discuss the use of tables to find the Fourier transform. Okay, not Fourier transform or for the inverse Fourier transform calculation. So we will mainly discuss the point C in this lecture. And this concept is also useful when you do problems by using partial fraction method. In order to find the inverse Fourier transform, mainly we are using the partial fraction method. To solve the problems in partial fraction method, we need the idea of this Fourier transform pairs. Okay, so this is a table which we use mainly for finding the inverse Fourier transform. Here you can see that the first one is a del of n, and this is a signal in time domain, and its transform is 1. It's a Fourier transform, and the ROC is given in the third column. And for del of n, the Fourier transform is 1, and the ROC is the entire Fourier plane. And detailed explanation is given in lecture 4. Okay, you need to remember this result, then only you can find the inverse Fourier transform. Okay, and you need to only remember this much result. And the second one is a raised to n into u of n. This is a standard signal, standard causal signal. So you need to remember it's a causal signal. Okay, it's a causal signal. Okay, and when the causal signal a raised to n into u of n and the transform is z by z minus a, and the modulus of z is greater than a, that is the ROC, and it is given in the detailed explanation of this particular problem is given in lecture 3, and you need to remember this result. And if you compare the the third one, you can see that again is z by z minus a. So for both the signals, the answer will be same. But it's very important when you choose this particular answer. Okay, if the signal is causal, the ROC is modulus of z greater than a, and when the signal is anti-causal, so this signal is actually representing the anti-causal form. Okay, so minus a raised to n into u of minus n minus 1. Always remember that there is a minus also. Okay, there is a minus. Okay, and u of minus n minus 1, not simply u of minus 1, and there is no minus at the power of a, and the answer will be same, but ROC is different. Here modulus of z greater than a, here modulus of z less than a. Again the explanation you can watch lecture 3. Another one is very important, the same signal, a slightly modified version. Okay, this almost you can compare these two questions. One is causal and anti-causal. Again here also you are given the causal and anti-causal signal simply multiplied by the n. Okay, here also we are multiplying by n the first two signal, and this is actually explained in differentiation property. Okay, differentiation in Z domain, or so these two questions are related to, and the explanation is given in lecture 12. Okay, it's a very important property. You need to watch this lecture 12, then you will get an idea of how we can conclude this answer like this. So if you look at here, it's slightly modified of the previous result. Okay, in denominator is z minus a the whole square, in the numerator there is factor a. Okay, a is z divided by z minus a the whole square, and the anti-causal part also the answer will be same, but I can see that ROC is causal, then modulus of z greater than a, and for anti-causal modulus of z less than a. Okay, and again you can compare these two questions similar to the first two, and here we are multiplying the same signal by n, so you can observe the result. And the third one also sometimes useful. Here the multiplication n plus 1. Okay, there are two factors. It's interesting because the final answer will be like this: the z by z minus a the whole square, the entire term whole square. There is no a also. Okay, here also you can see a square, but no, there is no square in the numerator part. Here z by z minus a the whole square, and ROZ is modulus of z. Okay, it's a combination of two signal. And another important result you need to remember about the cos and sine, okay, is a raised to n into cos omega 0 n into u of n. They are multiplying with cos and an exponential signal. Sometimes you can also expect a question simply cos omega n into u of n without a n. At that time you can simply substitute a is equal to 1. Okay, you can if you know one result, you can do many problems. Okay, again here you can remember 2 points. Here the numerator you can see z square minus a z cos omega 0, but if it is sine, there is only one term a z sine omega 0. In both cases denominator will be the same. So at least you need to remember the table, this results to solve the problems or to find the inverse is transform. Okay, now we'll try some problem based on the concept, okay, by using table is a transfer pairs. Okay, by using the standard result, how we can here you can see that we need to find the inverse is transform of the signal, and the signal is given by x of z is equal to z by z minus 1 minus z by z minus 1 by 2. Okay, actually you can see that there are two signals. Okay, the combination of two signals, because here you can apply the linearity property. Okay, you can individually find out the signal and you can combine. And it's very important when you find the inverse Isler transform, always verify the ROC part. Okay, in this question you can see that there are two poles. You can if you create the denominator, one is z is equal to 1 and another one is z is equal to 1 by 2. So in the ROC you can mark z is equal to 1 by 2 and z is equal to 1, and it is given that modulus of z less than 1 by 2. So modulus of z less than 1 by 2 means the circle, and inside the circle less than 1 by 2. So this is the ROC of the signal. So and this ROC is actually representing the anti-causal part. Okay, anti-causal part. If it is an anti-causal signal, now we need to decide one thing is very important. If we take this signal z by z minus 1 and if you compare the result, in both the case you can see that the result will be same if it is causal and anti-causal. Okay, and the decision is based on this ROC. If modulus of z is greater than a, you need to write the result in the form of a raised to n into u of n. If the ROC is modulus of z less than a, you need to write minus a raised to n into u of minus n minus 1. So if we compare here both the poles, okay, 1 by 2 and 1, and the ROC is inside the circle. So 1 by 2 represent this 1 by 2 and the pole 1 represent anti-causal signal. Okay, both represent anti-causal signal. So we need to write the result in terms of anti-causal form. Okay, so first we'll take z by z minus 1. Okay, and we need to write in form of anti-causal because this is the ROC, or by using this graph. So you can write minus, here in place of a it is 1, so you can write minus u of minus n minus 1. Okay, so we got the first one, and second signal is actually z by z minus 1 by 2. And for this particular signal, here you can see that a is 1 by 2, so you can write minus 1 by 2 the whole raised to n into u of minus n minus 1. So from the table you can see that, and here a minus also. Okay, so an extra minus here, so again we need to multiply with a minus, so it becomes plus. So the final result you can write like this: x of n is equal to The first term is minus u of minus n minus 1, and the second term is 1 by 2 the whole raised to n into u of minus n minus 1. Okay, if you rearrange this particular thing, you will get 1 by 2 the whole raised to n minus 1, because u of minus n minus 1 is common, so u of minus n minus 1 is a common term, so this will be the answer, and this is purely an anti-causal signal. Okay, now we'll check the next question. Here again the factors are same, z by z minus 1 and z by z minus 1 by 2, but the ROC is given modulus of z greater than 1. If modulus of z greater than 1 means we need to verify the poles. One pole is at 1, another one is 1 by 2. So I can mark here, one is at 1 by 2, another one is at 1, and the ROC you can see that modulus of z greater than, so the shaded portion. So this is the ROC. Okay, and this represents actually a causal signal. This is a form of a causal signal. So this ROC representing a causal signal. So we need to choose the answer a raised to n into u of n form. So if you write z by z minus 1, and there are two options, a causal and anti-causal, but from the ROC we got the idea that the each signal, so z by z minus 1 and z by z minus 1 by 2 both represent a causal, because ROC lies outside this pole and exterior of the poles. So you can write a raised to n into u of n. Here a is equal to 1, so simply you can write u of n. And the second signal z by z minus 1 by 2, and here a is 1 by 2, so you can write 1 by 2 the whole raised to n into u of n, but in the question there is a minus also, so you can put a minus here, and from this you can write x of n is equal to u of n minus 1 by 2 the whole raised to n into u of n. Okay, so you can write 1 minus 1 by 2 the whole raised to n, u of n is a common term, so u of n is a purely a causal signal. Okay, it's only in positive side. You can look at this previous question. Both question the factors are same, but ROC is different. One is inside the circle, one is outside the circle. Okay, that's why we got two answers. Now we'll discuss another question. In this question actually three parts, so again we will verify the poles. So you can see that again in this question 1 and 2, okay, are the poles. So you can indicate here one pole at 1, another one is at 2. Okay, there are multiple poles at 2, and the ROC is given modulus of z greater than 2, means outside the circle. So this shaded portion represent the ROC. So based on this we can say that this represent ROC of a causal signal. Okay, okay, outside the circle, greater than a pole, so both the poles lies inside the circle and the ROC outside these poles. So both or all these terms represent z minus 1 or z minus 2, all signal we need to write in terms of causal form. Okay, causal and causal. Okay, so based on that if you write z by z minus 1, okay, based on this causal signal you can write simply u of n, and second one z by z minus 2, the inverse is a transform, you can write 2 raised to n into u of n. Okay, and there is a minus also, so we need to put a minus here, and the last term is z by z minus 2 the whole square. Okay, then we cannot use this particular result, because it is only z by z minus a. When there is z minus 2 the whole square, definitely there will be a term called n into. Okay, so again the ROC is representing a causal signal, so from the table it is clear, n into a raised to n into u of n is something similar to that, z by z minus a the whole square, denominator there is a square term. Okay, it's almost similar to that. but you can see that there is an a, but in this case there is no a, so we need to slightly modify this. So if it is a 2, okay, if it is a 2, you can write like this. It's simply n into 2 raised to n into e of n, okay, but unfortunately there is no 2, so we need to divide by 1 by 2, so that 1 by 2 comes here, so it becomes n into 2 raised to n minus 1, and here it is 2 raised to 1. When it goes to numerator, it becomes 2 raised to minus 1, so that's why 2 raised to n minus 1 into u of n. So we got all the terms. Now we can write the result. X of n is equal to, you can see that u of n is common, so you can write 1 minus 2 raised to n minus n into 2 raised to n minus 1 into u of n. Okay, u of n is common. Again, it represents purely a causal signal. Okay. Now we'll discuss another question. In this question, there are 4 terms, and we will consider each one. And before writing the equation, we need to verify the ROC. Okay, here the ROC is given modulus of z less than 1, and modulus of z less than 1 means okay, and other poles also we can verify is 1 and 2. Okay, so you can see one pole at 1 and another one at 2. Okay, and the ROC is the shaded portion. Okay, ROC modulus of z less than 1, so this represent an anti-causal signal. Okay, this 1 and 2 represent an anti-causal signal, so we need to write the result in terms of anti-causal. So you can take this term and this term in anti-causal form. There are 2 options. Okay, so we need to prefer anti-causal in this case. So if you write z by z minus 1 in anti-causal form, means we need to write minus u of minus n minus 1, and in the equation there is a minus, so we need to write minus, so it becomes plus. And another term, it's z by z minus 2. Okay, you write this term again, you need to write minus 2 raised to n into u of minus n minus 1, and next we need to consider the first term. There is a constant term, so before that there is a 1 by 2, so we need to put a 1 by 2 here. So here also 1 by 2 into, so you can modify this. It becomes minus 2 raised to n minus 1 into u of minus n minus 1, and the other term you can write, it's simply 3 by 2 into 1. So if you look at here, if the Z transform of del of n is 1, okay, and the ROC is all Z, means if you are getting a constant term 1, the inverse is a transform. Okay, inverse is a transform can be written as del of n. Here it is multiplied by 3 by 2, so 3 by 2 into, so you can write 3 by 2 into del of n. And next quantity is z raised to 1. Okay, the first term z raised to 1. If it is del of n minus 1, we know that by time shifting property it's z raised to minus n. Okay, here this m is equal to minus 1, so you will get like this. It's simply z raised to n plus 1. Okay, and there is also constant, so we need to multiply by 2. Okay, so we can combine the result. X of n is equal to 2 del of n plus 1 plus 3 by 2 del of n, and the next term is z minus 1, so you need to write plus u of minus n minus 1. Okay, and next term is minus 2 raised to n minus 1 u of minus n minus 1. Okay, this will be the answer.